So now this problem says evaluate the limit using the Taylor series about x equals 0. So the limit here is cosine of x minus 1 over x squared as x goes to 0. Now again, we have to use a Taylor series here. So now first I have to understand what the Taylor series of cosine is. And if you're not sure, what does that mean then? That means I have to go through a ton of derivatives. So here's f of x equals cosine of x. So then f prime of x, that's going to equal negative sine of x. Now all I'm going to do is run through a bunch of these. So now I just did a bunch of them because we have to do a lot to see the pattern. Now I did up to 6 derivatives there. Now all I'm going to do is we need that first part, that f of a. So now that means f of 0 for this one since we're centered about 0. So that means that's going to be the cosine of 0, which equals 1. So then for this one, f of 0 is negative 0, which is 0. Now I'm just going to run through the rest of these. All right, so looking at this problem, notice that I have the alternating signs here. Also, I have this one here, which is a positive, negative, positive. And those other terms with the zeros, we don't have to worry about those. So that's going to be our part that we're going to put this series together on. So then for my first one, remember, it's f of a. So that's going to be my 1. So here, I'll write it out for you. So then the cosine of x equals 1 minus I'll just say plus negative 1 over 2 factorial x squared since we're centered about 0. Okay. Plus negative 1 squared 4 factorial x to the 4th. Now keep in mind here, I'm skipping the third because it's 0. And I'm skipping the first derivative because it's 0. So that would eliminate this one here and this one here. So just kind of keep that in mind as we go through this. Actually, I should write it that way. So then I jump to the 4th right away. So the next one would be plus negative 1 cubed over 6 factorial x to the 6th. And if you notice, that would cause that alternating pattern as well. So this would be the first power. This would be the second, which would make it even. So it's a positive 1, and that's what we see here. And then the third would make it negative again, like we see here. So that's one way I could mimic that pattern. So then I'd go plus, and then dot, dot, dot. And that's an alternating sign, so let's try to be aware of that for our next one. We may have to do one more to see the pattern a little better. Maybe I will go one more for that sake. So then that would be plus negative 1 to the 4th over 8 factorial x to the 8th, okay, plus dot, dot, dot. And what's our nth one going to be now? It'll be negative 1 to the n. Is it going to be the n? So at 0, it's 1, yeah. And then it'll be 1. So that works for the top. And then on the bottom, it's going to be n factorial. No, because that's an even. So it should be maybe 2n factorial. Because that would be 1, 2, 4, 6, 8. So 0, 1, yep, so that would work. And then I would have x to the, would it be 2n? Because remember, I'm starting from 0 here. So when I do 0 for everything, oops, let me fix my factorial a little further over. So remember, we want that pattern where it's even numbers. So then I plug in a 0 here. So now it's going to be 0 factorial on the bottom. And then on the top at 0, that's going to be a positive 1. 0 factorial is 1, just so you know. And then that 0, that's going to give me a 1, so that'll be 0. So then yes, I would get a 1 for the first one. So now let's take a look at the second one. So then that would be a 1. So that on the bottom I'd get a 2 factorial. On the top I would get a negative 1. And then for this one, if I plugged in a 1, I would get a 1 times 2, which is 2. All right, so we see that that works. Oops, to the end. So then if I'm going to create the series then would be, don't forget my plus dot dot dot, because it does go on. And then that series is going to be n equals 0 to infinity. And then I'm going to end up with a negative 1 to the n. Oops, terrible looking n. Over 2n factorial x to the 2n. So that's actually going to be my series for this thing. So that's what we're looking for the top. But look at all the numbers here that we get for this series. So now, if you look at the top of this, oops, it's cosine of x minus 1. So if I take cosine of x and I take minus 1, it's actually going to take this 1 away here, because I'm going to minus the 1. So think about it this way. If I minus 1 on that side, I have to minus 1 on this side, and it'll take that 1 away. So that's kind of the idea there. So then this is going to be one minus x squared over 2 factorial plus x4 over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot, and then minus 1. So those are actually going to cross off, and that's what I was talking about a minute ago. So this actually equals negative x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot, and it just keeps going. Now when I think about the bottom of this thing, over x squared, now if I take cosine of x minus 1 over x squared, I'm going to get this negative x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot, all over x squared. Now this is going to cancel with that, and then this is going to take 2 of those away. So this is just going to be x squared left. This is going to be, cancel that, and it's going to be x to the 4th left up there. So this is what I'm going to end up with. So this means if I have the limit now if I have this limit, this is going to be the limit as x goes to 0 of negative 1/2, because 2 factorial is just 2, plus x squared over 4 factorial minus x to the 4th over 6 factorial plus dot dot dot. All of these, if you think about it, are just going to go to 0. Everything after that is just going to go to 0. So dot 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 is all going to go to 0. And then I'm going to be left with negative 1/2. So that would be the answer for this one, negative 1/2. So that's what it means when I have to take the Taylor series and I have to use it to find a limit. So again, it generally is a little faster than this, but again, this is an explanatory video as well. So a lot of those I would already know, and to get the 1/2 would be a little more immediate. So there it is.